Hi, my name is Hardeep Singh. I'm the principal security architect at a fintech called Upstart. The world is changing. The way we build products are changing. Where we build products are changing. From where we build products are changing. How those products are distributed is changing. In fact, the whole product cycle is changing. Today, we are going to discuss the risks that these changes bring into the ecosystem and how to mitigate them as far as possible. This is the mandatory. So over the last 20 years, or from the last millennium, software has evolved very rapidly, the way we build products. We used to build monolith applications that were installed on customers' infrastructure. We have evolved to software as a service. We used to build generally homegrown code. Everything was dependent on what we built. Today, it's a mashup of services, which are further a mashup of other services, and the dependency cycle is all down the food chain. We used to release maybe one or two product releases once a year, or once or twice a year. Now we do it twice a week. CI/CD, continuous integration, continuous deployment. We have moved from on-prem infrastructure to the public cloud. And when I say it's the public cloud, it means it literally is accessible to the public. And the last nail in the coffin, well, at least till now, is COVID basically changed the whole work culture. Most of the folks used to work from the office. Occasionally, there was a working from home. But generally, it was in the presence of somebody. Today, we've evolved to a remote work culture. Now, humans haven't evolved as rapidly, and security definitely has not. Security is lagging. We are using the same archaic methodologies, and that poses a risk. So we're going to figure out how to mitigate those risks and how to understand the consequences of those risks. So the question is, what's the big deal? People used to work from home before also. What's changed now? Well, working from home occasionally is not the same as working remote. It's the digital nomad that brings the risk. What I like to think of it is that we move from a single B to a 4B, where before you were working from the privacy of your bedroom, where you were surrounded by folks you could trust, in an environment that you could trust, to a bar, a barista, a beach, or a bed and breakfast. You're surrounded by strangers, connected to insecure networks or potentially malicious networks. And the nature of the job hasn't changed. Okay? You're still doing the same job you were supposed to do before, so you have to have access. The access doesn't change. You have to have the privileges. The privileges don't change. Your work didn't change. But where you are located changed. How you get to that infrastructure changed. The guardrails around that environment changed. And an interesting phenomenon has happened that as you work from home, the boundaries between work and personal have become blurred. So people have a tendency to use the same device, the corporate device, as their personal device. Or vice versa, if you're a smaller company, you basically say, hey, bring your own device, and we'll give you access. And that introduces challenges. Okay? Again, how much of it is an issue? It's how evolved your culture is. versus how much of the risk you're willing to take, right? So I'll touch these 4 points that impact our risk specifically for workers that are in remote sites. The first one is the location, right? And that's the primary thing. You are anywhere in the globe. That's the company's, a lot of companies advertise, we are a global company and you can work from anywhere. Two, where the risk appetite is less, you can only work either from home, and that's still remote, or you are inside the home country, and then in between somewhere. Access, again, starting from smaller companies where there are fewer employees, everybody's got access to everything, including infrastructure, code, data, to where the companies have matured and they give you just-in-time access based on your business need. Okay, and then the usage is, this is more of the device that you give to your employee. And are you allowing them to use it for their personal and private and corporate? Or you block them from doing anything personal from it. And the final one is kind of a converse of the previous one, is that where you say bring your own device, bring your own Git, it happens, right? Bring your own code, well, that also happens. With ChatGPT, probably can get anybody's code. And then the final one, which I would consider is going back in time, but is probably the most secure, is give a desktop to your employee. Let them cart that to a bar or a barista, right? But obviously that's not practical, but that's the evolution of the culture and the risk. So I'll now dive down into each one of those 4 segments. What's the risk of the location risk? Public workspaces, okay? As I said, you do not know what you're connecting to. And there are multiple ways of rogue networks masquerading as your favorite barista's network. There are numerous ways of knocking you out from an existing network and putting you onto the rogue network. And once you are on that rogue network, well, all bets are off. Man in the middle, password, malware, etc. And then, of course, there's the traditional shoulder surfing, listening to conversations, spear phishing. Somebody knows you are coming to a specific coffee house or a bar on a daily basis. You are now a target. And if they know which company you are advertising because you wear the jacket that the company gave you or the T-shirt, they are now looking at how can they target you. And then, of course, the last one, which has always been there, the snatch and grab. You go to get a refill and laptop's gone. Now, the laptop could have been stolen from your car also. That was possible, but it was locked. You were logged out. Now this is an active laptop. Somebody's actually moving away and you're logged in. In a sense, they are you. That device is you. So the trust is on the device. And going down, I'll explain how the device and you can be separated to mitigate the risk, as well as how they interact with each other. So what do you do to mitigate the risk, to reduce the risk? Well, first of all, we are all logical people, so we come to a logical number. We are number-based. If I can come to a number, I can say, okay, above the number, below the number, here's my risk, right? So let's give it and this is just, just a basic methodology, is I give a max trust, a partial trust, and a minimal trust. And then obviously no trust. And that can be based on where you're located, you know the IPs, you trust the IPs, you trust the domains, or you know it is an open network you're connecting to. You are in some location, you're not in the same country, you have moved outside the country, depending on what your requirements are. And then you are on in a restricted country, that is on the US government's restricted, or any other countries, restricted countries that you've gone to. At that point, basically, either you don't work or you give them a burner or something or the other, right? And so why are we doing this? Why are we doing this trust thing? Well, we're going to use this trust calculation to figure out what your privileges are and what the device privileges are and how the device is going to behave as you move between these trust boundaries. So the device user experience. As you're moving from one trust boundary to the other trust boundary, your user experience changes. You could be basically blocked from doing anything on the device. 2, you could have the full capabilities of being an admin on the device and installing stuff on it. Timeouts can change. The screen timeouts can go from like half an hour or 15 minutes, standard, to like 2 minutes, or constantly refresh the screen. As you move between trust boundaries, your credential caches could be removed. You move from one place to the other, just blow away the cache. Peripherals, obviously, depending on the appetite for risk, companies might not even give any access to peripherals, or there are printers and all. And then finally, the MFA. MFA can move from your regular YubiKey or text to a biometrics. You need to physically touch, and your fingerprints are known. What is the impact on the device trust? Not your trust, but the device trust. At the infrastructure level, well, if you are in a trusted environment, you have the full capabilities, if you are allowed to have the full capability. From that device, when you log in, you will maintain your privileges. Or you could have some access to staging or development environment from a semi-privileged location. Same with logs. Docs are a little different. You could give access to certain dogs which are not kind of sensitive. But then again, at the extreme end is you have the ability to configure those environments. Again, the job functions of remote people does not change. Some of them will be admins. Some of them will have privileges. So the main thing is to tighten those privileges based on where they are located and where you trust that location. Code, again, this is interesting. It's a hot point of discussion in the engineering world, where folks think that, oh, I should be able to do my pull requests from anywhere. I'm on the move. I whip up my phone. Somebody's done a PR. I approve it or disapprove it. And I'll leave it there because that is an appetite. And then, of course, data. Now, somebody's going to say, sensitive data. Why would they have access to sensitive data? Well, if they had access to sensitive data before, just because they became remote, it didn't evolve. They still have access to the data. That is the problem. We are following the old methodologies, even though the work culture has changed. So and this is a very basic, chart on how you can calculate. Obviously, it will be much more complex than this. Trust is based on the device. It's a corporate device. It's got a cert or some token on the device. Hence, you trust it. It's on a trusted IP. We have that IP. We know you come from that on a regular basis. Or these are some domains that we are trusting, and hence it is trusted. It's trusted, and it's maximum trust. The second level is, it's not the fully trusted domain, but it is, we know these are the domains that Starbucks has, or a university has, or something or the other. And hence, like I'm coming to RSA, maybe I can ask my folks that, hey, can you take the RSA domains and put them in the trust boundary? And then finally, of course, the ad hoc ones, even you're in an airport or just moving around. So what do you do? Again, very simple example. You have agents running on your device, okay, which are monitoring your movement. Big Brother's always on the device and always watching and always monitoring. And as you move, it's checking what are you connecting to, what kind of Wi-Fi. It can actually at that point figure out if the Wi-Fi could be malicious or not. If it doesn't, at least it knows you have moved from one trust boundary to the other. It sends this information to some central analytic system. At the network layer also, as you're moving, you can track stuff that's happening at the network layer. And then once you've got this information, you come out with your trust calculation. And then you feed this back to the device, to the network, to your firewalls, as well as to your single sign-on IAM methodologies. And using that, now you take decisions on access privileges, device behavior, everything else. So the first segment was on the device, how the device changes. Now we'll go into what is the access. How is the impact of an employee's access to the ecosystem. Again, at the lower end, probably startups, smaller companies, where there are not that many people, so everybody's got access to the whole infrastructure. And then you go into the other end where only subject matter experts, the DevOps folks or the IT folks will have access to that infrastructure. And then in between, the teams, the verticals, et cetera, et cetera. Code, again, as I said, it's a contentious point. Some companies' culture is that all engineers should have access to all code. That's the nature of the engineering world. It's a cultural thing. It never used to be there 20 years back, and people were building products. But now that is the mantra. Engineers have to have access to everything. Again, not a good idea, but most mature companies would say at least have a reason to have access. Are you participating in that? Are you doing some pull requests, right? And then the data. Again, smaller companies, access to all data, and mature companies based on business need. What I mean is business need is that for that specific piece of data, not all data, that specific piece of data, what is your business need? Okay? And the development piece, again, I'm throwing it in because it's so wide. And it is also something that engineers are very passionate about. Most of the development is done off the personal device, not personal, on your devices. But where you would like to move is a cloud-based IDE, because there you can control what is being pulled down, you can monitor everything much easier, and there is no personal usage of the cloud device, unlike the laptop. Okay, so how do you get into that kind of world? So today what we have is what I call is just in case. Just in case, in the middle of the night, I get a pager duty call, hence I need access. Just in case maybe in a month or two, I might need access to this data for creating some reports, for some power that be, hence I need access to the data. That is the current situation in most companies, just in case. And hence you have permanent access, which was okay before we became all remote. Now you have a lot of people with a lot of permanent privileged access all the time. So, and what's the process is, if there is a process, there's a group, maybe if there's a single sign-on, I'm just assuming that there are groups which give you access to certain areas of your environment or your data or your infrastructure. And privileges are granted to the group. And if you are a member of the group, you have access to that. And there is a process by which you can, either there's an owner or somebody who approves that process and does. Now that is if you are matured enough. If you aren't, then all bets are off. Okay? Now what we want to move is to a just-in-time environment. What do I mean by just-in-time? Yes, just-in-case exists. You still have to be, there has to be a business justification for being in a group that has privileges. Even though you're not accessing, you still have privileges to access it. That business justification has to be done. It has to be approved. It has to go through the proper flow. That's the traditional flow. But being in the just-in-time, just-in-case group does not mean you have access to the resource. You get access to the resource just in time. And what's the flow? You do, let's say it's all self-managed. You go and apply for just-in-time. It looks at the just-in-case group. If you're a member of the just-in-case group, it gives it to you. If you're not a member of the just-in-case group, it basically kicks it back and says, please go and get access into that. And that no longer is just-in-time. You have to be in the just-in-case. Now, obviously, if there is a proper single sign-on access, that means you have auth N and auth Z into your end target, it'll just flow through because the group will go through and you're done. If it doesn't, if it has partial, but it still has API access, then you can write some kind of service that will sync up the user and the roles and the privileges, etc. And if there is no API access, and there are vendors who don't have any API access, then all bets are off. You do not have just-in-time. And we'll discuss that later when we get to the vendor piece. So we are giving access. We have to give access. That's how the business works. So what do we do about it? We trust, because that was why we hired somebody, but we verify. You trust that they will do the job, but you're suspicious also. So you set up your gates and your monitoring. At the device level, you are trusting them to do the right thing with the data. But you're also tracking them. Are they making copies? Where is that data on the device being moved around? You gave them privileges to be admins. But what did they do when they became admins? So you need to figure that one out. At the network layer, you gave the company access and the employees access to any endpoint, right? But now you need to make sure that they are not going to, not just malicious sites, they're not uploading the data. Downloading is one thing, they get some rootkits, etc. If you got a good defense, that'll work. It's the uploading of the data. That's where the danger is. If somebody can shoulder surf, yeah, the blast radius is small. If somebody can just take that whole volume, and if you're reading all the news, it's the huge volumes of the terabytes of data that have gone out that have created the big mess. Not a couple of records or 100 records or something. And then you're, again, looking for anomalous behavior on the part of the device, on the part of the employee, okay? And you're monitoring. And then obviously there are folks out there who think they know better than security. And they get exceptions. Either they are in the power position. So what do? You set up a phishing campaign. Do spear phishing on especially the folks who think they know what they're doing, and catch them and show them what the consequences are. And then, to sum it up, there are other issues with the remote workers, collaboration. Before, you get in front of a whiteboard, write stuff, and maybe if there were some secrets to be shared, you would just go and show it to the person. Now we are sharing secrets over insecure channels, Slack channels, GitHub, right? Zoom calls, you name it. And emails, always my favorite. The other problem is that we are used to dealing with the corporate as an unknown entity where emails come to us. And there are links in the email telling us what to do. So we are tuned that if an email comes, which is coming from a corporate executive or somebody, we will click on that without even questioning it. And that is the fundamental flaw. If you try to do a phishing campaign and just test it out, send out the emails from somebody in HR and see how many fishes you'll catch. And you'll be surprised that folks who claim that they knew everything about security might be giving out their credentials. Again, nature of the business, admin privileges are given out because you have to. People are remotely located. They're not in one place. So just to make sure that there's somebody out there, you have spread out the privileges. And then certain things which were required, like you go to Amazon and there's a root credential, they require a physical MFA. Well, that doesn't work because the employees are located in 4 different places. Where do you put the physical MFA, right? And then obviously the incident handling, when an incident happened, you got into a war room, people there face to face, things could be discussed. Now it's all remote. You really can't have that kind of control over an incident when it happens. So you have to practice this. Practice it more and more and more. If you did it once a year, now you do it 4 times a year. And then finally, offboarding employees. And we've seen how that has happened on remote employees. If you go to one extreme, you really have bad press. Employees are just knocked out and they get their emails on their personal email saying, oh, you are no longer an employee. And then you have the other end where you have a disgruntled employee who has access to the environment or at least to the device. How do you handle that? So that was on the first part of my talk was remote. I'll briefly touch on the other 2 aspects is the dependency on other people who are also dependent on other people. Okay? So what's the big deal, right? Well, vendors or third parties have access to your crown jewels. They have access to your data. They have access to your infrastructure. They have access to your code. Now, well, big deal are my engineers also have access to the same thing. Yes, but I know what happens in the security profile of my company. I set the guardrails. I know the SDLC process. I know the IAM process. I know all that. Do I know whether the vendor is doing the same thing? It's opaque. In my company, I trust and I verify. With the vendor, I only trust, no verify. And I think there was a very famous attack, 2019 or something, Merck's attack or something, where the Russians used a Ukrainian service provider to attack I think, Dutch shipping company and brought the world shipping down. Why? The weakest link. A small mom and pop store was put into the ecosystem. And that's going to happen more and more. We've actually accelerated the pace on that. So the vendors have access to everything. You don't have access to maybe some access logs. But you definitely don't have any understanding on the dependencies the vendor has. They could have even a smaller vendor down the chain. Okay? Now, if I am a hacker worth my salt and it's a business, why would I go after a big bank who has all the resources? Why would I go after Fort Knox? I would go after the vendor who participates in the Fort Knox, or a vendor who participates with the vendor who goes after, because that is where the weakness is, and then leverage and attack from there. And a lot of these third parties, they are startups or just post-startups, and they don't have the resources. And the other problem is when you go with the vendor, you're locked in with the vendor. Even when something happens, you can't just pull out. You cross your fingers and hope for the best, right? And then if you have a lot of vendors, integrating them into your single sign-on is a nightmare. Not all of them have all the single sign-on. And then unless you have a robust mechanism to manage these vendors, the access control, the groups, et cetera, you are in a lot of pain. And a lot of them might not even have MFA. So what do you do about it? Well, at least at a basic, if you have to have a vendor, do the due diligence if they have some security. Obviously you can start with the basic compliance. Do they have a SOC or some ISO, some certification that says, yep, somebody has gone through that list and checked it. If they don't have it, just don't even waste your time. Then check whether they have some basic integration, single sign-on, et cetera. If they don't have it, be careful, don't go there. If there's an alternative, go with the alternative. Then the bigger one is it a high-risk vendor? Am I giving my crown jewels to this? Is there data access? Are they in my infrastructure? If that is so, then check if they have an alternative which is self-hosted. Not hosted on their site, but hosted on yours. You're still paying them, the vendor's getting the money. It's not like any different. But now it's within your trust boundaries. If they don't have it, then do a thorough threat model exercise. Call in their security guys. Do the same kind of security review that you would do to your services and microservices. And if they fail, don't go with them. So, what's the plan? Identify your high-risk vendors and figure out how you can get them to do a security review and eventually look for alternatives if possible. Okay? With the IAM, identify again. First 2 weeks is identify what you can do. Okay? And then the next quarter or so is the action that you're going to do. And the whole year, in the next year, try to remediate it so that the risk is reduced. Okay? Bring in infrastructure as code, get the logs in so you can monitor it, and eventually look at monitoring the vendors' news. If they are in the news, you should know about it. And now the final piece of the puzzle here is the cloud native. Now this has been happening slowly. We've scaled from the on-prem world to the global. In the on-prem world 20 years back, getting access to production was virtually impossible. If there was a production, it was like they had the DMZ, et cetera, very few people had access to that kind of environment. Now, everybody's got access, DevOps has got access, developers have access. Before, IT used to manage everything for you. And everybody remembers how bureaucratic and slow and painful it was. But the beauty of that was it also prevented weaknesses from spreading fast. Okay? Now, vulnerabilities spread at the speed of API. Infrastructure scale at the speed of API. You have more privileges, a developer has more privileges than an IT guy had 20 years back. And they can build an infrastructure within minutes, which would take years of discussion and arguments to get there. And changes are really fast. So everything accelerates. And so I'm going to focus on the role of the developer. So we moved from IT to DevOps, and then somehow we have corporate culture has accepted that every developer should be able to manage their own infrastructure. Okay? Now the problem with that is the developer is not a subject matter expert. Yes, you can go into the cloud, and they made it very easy for people to spin up infrastructure. That's their job. They're trying to sell that. But there are guardrails. There are fundamental things that need to be understood, and you need to be a subject matter expert. They're not used to running tier 0 services, so what they'll do is they'll go for third-party solutions. Rather than your DevOps guy, your IT guy will say, oh, maybe I'll set it up. The developer is more focused on the functionality. They don't care about security baselines and guardrails, etc. They need a function. They need a database. They say, hey, I need a database. I need a non-SQL database. I need this kind of functionality. Oh, the cloud provider is providing me that service. I'm going to use it. They don't care about security, scalability, availability, and cost. And of course, the same person now is building the code, managing the infrastructure, managing the logs, and you can understand the toxic mix and the compliance nightmare that you're putting in. So how do you reduce it? Well, first of all, try to introduce infrastructure as code. Okay? No manual changes to the infrastructure, at least the production infrastructure. That way, at least somebody's thought through the process. Everything comes in through a VPN. Make sure there's a single sign-on. Switch to just-in-time, at least for your product environment, and maybe staging. Have this guardrails around that environment, guardrails around the accounts, about the organizational units, and then constantly scan and monitor for vulnerabilities. Trust but verify. So infrastructure as code is basically, I'm going to give an example of Git. You have your libraries, you have your configuration. Somebody who's a subject matter expert has set it up for you. You basically then allow the developers to make changes to the configurations within the constraints of the guardrails. Okay? Even then, trust but verify. You have scanners which are scanning the changes. As the PRs are being merged, the scanners run. They check them against baselines that have been created. And if they pass, then they're deployed. And then you're also monitoring if there are any manual changes. If there are manual changes, alert. Okay? So what do we want to do in the next couple of weeks to the next year? Define your security baselines. Okay? Build a robust change management process. Identify ownership. That's a big thing which shouldn't be an issue, but people build stuff and they don't even tag it. So when you're trying to mess around with it in a production environment, you can't do anything about it. Have an owner for an asset. Have an owner for data. Have owners for everything. Okay? And then you set up the guardrails. You use this information, your baselines and all, at a data level, encrypt at a field level rather than at the resource level. And then give access to specific fields based on a business. The more granular the access is, the better. So why are we having this discussion today, right? This is very obvious. Well, unfortunately, it's not. There's a misunderstanding in organizations of the role of security. Most of the time, and this is coming from traditional world, security was compliance. You got the certifications, and maybe at the boundary defense, networks and all, you had that, and that was it. Security doesn't cost, security doesn't bring anything to the bottom line. It's a cost center. It's just like IT, but you can't quantify. The only time you can quantify the impact of security is when there's a hack. And that's a negative way of it, right? It introduces friction into the system. No engineer likes it. It affects design decisions. And obviously takes away privileges. And then the final one is security through obscurity. You were lucky. Nobody targeted you, so you feel safe. And the company feels they've got bigger problems to focus on, till security becomes a bigger problem. Now, what's the problem? You start patching security things. When a gap is found, you patch it. It's a whack-a-mole. Over time, these patches become expensive to maintain. They will not scale. As the company scales, they will not scale. Exceptions become the norm, and then people get used to those exceptions. Okay? All of these calculations will pile up and end up costing more, and that cost will then take out money from the kitty that you would have used to make a more secure environment. So this is the final take on an overall, like what should we be doing at the infrastructure level, at the employee, at the operational. And I've touched most of those. I'll just look at the last one, which is risk. Your operational risk is inversely proportional to the maturity of your security domains. Break up your security into the subdomains: corporate, infra, vulnerability management, SecOps, and then focus on each one of them. And then bring the controls that are your risk controls and map them to these. And every effort you do should be directly quantifiable to how much of the risk are you reducing based on a control. But at the domain level, because the domain gives you a higher viewpoint. And you can say, okay, I'm maturing this domain at this level. And then finally, you should have the ability to recover from a breach. Breach will happen. It's not a question of if, it's a question of when. Are you prepared for it? Practice, practice, practice. So, what's the conclusion? The new world comes at a risk. There are consequences to the work culture changes, to the infrastructure changes, to the way products are built. Understand those. There'll be consequences if you don't. And this is the biggest one: accept the cost. Accept the cost of mitigating the risk. There's no silver bullet. It is going to cost money. And then build the plan. And the biggest thing is constantly check and evolve it. As I'm speaking, security is evolving. The risk to security, ChatGPT is going to introduce one of the biggest risks to security that's coming in as I'm speaking. Okay? Quantum is going to make it even worse. We have to evolve. Security has to evolve faster than actually products are evolving. And in the words of Andy Grove, only the paranoid will survive. Thank you. Any questions?
Hello. That was really interesting, by the way. When you mentioned the shift from just-in-case to just-in-time access, so granting the access usually is not a problem. They're really happy to get it. But what about you when you take it back? So what would you trust or see or implement to make sure that the just-in-time ends in time?
So the just-in-time is done through a service or an infrastructure as code. The just-in-case is done through a review. Why do you need it? And for how long? For 1 year, I need this just-in-case. The just-in-time is when somebody applies for it, they give a time. And the maximum timeline could be an 8 hours timeline. Okay? And there's a cron job or whatever, it doesn't really matter. The service basically blows you out at the point of, so either they'll take you out of the group if it is a single sign on follow through, otherwise it'll delete your users.
So you take it back as code too. So you give them time to do whatever, and I would tend to see that the stricter you get, the less well this will go with devs. But if you say, you know what, have 8 hours, have
Yes.
at it, and then take it
Yeah.
back forcefully.
Yes.
Okay.
Yeah, and you will define why you need it, for how long you need it, and that is auditable. And if it's a high risk resource, you could even send it to the manager. That this guy at this point is asking access to this.
Thanks.
Any other questions? All right, thank you.